Now let's learn how to differentiate the sine and the cosine functions. So we're going to go back to the definition of the derivative. So the derivative with respect to x of sine x is equal to the limit as h goes to 0 of sine of x plus h minus sine x divided by h. We know the addition formula for sine and cosine, so we apply the addition formula for sine, so that will be the limit as h goes to 0. Then we have sine x cosine h plus cosine x sine h minus sine x divided by h. We can factor out of the limit things that don't depend on h. So let's start with cosine x. So that will be cosine x times the limit as h goes to 0. We have a sine h over h. So this limit. And then we have a sine x, so plus sine x times the limit as h goes to 0. And we have a cosine h minus 1 divided by h. So cosine h minus 1 divided by h. Okay? So we end up having to consider these two limits. Let's just do it again for a cosine. So the derivative with respect to x of cosine x equals the limit as h goes to 0, cosine x plus h minus cosine x divided by h. Again, we can use the addition formula for cosine. So that's the limit as h goes to 0, cosine x cosine h minus sine x sine h for a cosine x plus h minus cosine x divided by h. And if we do the same thing, we can see another sine h over h, but that one is now multiplied by minus sine x, so we can write that as negative sine x times the limit as h goes to 0 of sine h over h. So this first limit again. And then if we factor out the cosine x this time, then we'll have, again, the cosine h minus 1 over h. So that would be plus cosine x times the limit as h goes to 0. The same limit here, cosine h minus 1 over h. Okay, so we have these two expressions for the derivative of the trig functions, the derivative of sine x and the derivative of the cosine x. So what we need to do is figure out what are the values of these limits. Before we do that, let's consider what the meaning is. So if we looked at the derivative with respect to x of sine x evaluated at x equals 0, then we would end up with sine of h minus sine of 0, but sine of 0 is 0, so that would just be sine h over h. So that is, in fact, equal to the limit as h goes to 0 of sine h over h. So this first limit here is just the value of the derivative of sine x at x equals 0. What about the second limit? Then we would expect the second limit, d dx of cosine x at x equals 0. If we look at the cosine formula, it would be cosine h minus cosine 0. Cosine 0 now is 1, So cosine h minus 1 divided by h. So this is the limit as h goes to 0 of cosine h minus 1 divided by h. And that's just the second limit formula. So what we have then is the derivative of sine x is equal to cosine x times the derivative of sine at x equals 0 plus sine x times the derivative of cosine at x equals 0. And similarly, we have the derivative of cosine x equals minus sine x times the derivative of sine at x equals 0 plus cosine x times the derivative of cosine at x equals 0. So the key here is to figure out what are the derivatives of sine and cosine at x equals 0. To do that, let's look at a graph of these functions. So here is a graph of sine x and cosine x. If we look at cosine x first, we all know that it has a maximum at x equals 0. So this is our x-axis, this is our y-axis. So the slope of the tangent line to the curve at x equals 0 will be 0. So this value here, the derivative of cosine x at x equals 0 is equal to 0. This one is 0. Okay? On the other hand, if we look at the sine function, the slope at the origin is 1. Okay? This is a fact that one can prove in trigonometry. There are different ways to show that the slope is 1. But here we'll just take it as part of our definition of the sine function. So that means that this limit here is equal to 1. So now if we go back to this, since the limit of the cosine here is 0 and here is 0, then we end up with our key result, which is that the derivative of the sine function is equal to the cosine function, and the derivative of the cosine function is equal to the negative of the sine function. Okay. And that is exactly what you need to remember. So let me review. We're trying to find the derivatives of the sine and the cosine. If we use the definition of the derivative and the addition formula, we can get that the derivative of the sine function is the cosine function times the slope of the sine at x equals 0, plus the sine function times the slope of the cosine at x equals 0. But the slope of the sine at x equals 0 is 1. The slope of the cosine at x equals 0 is 0. So the derivative of the sine function is the cosine function. And likewise, the derivative of the cosine function is the negative of the sine function. Two very important results that you should memorize. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.